Okay, we're going to start our next topic on derivatives. So we've looked at power rule, product rule, quotient rule, and chain rule. So our next and sort of our last type is implicit. And what implicit is just a different way of approaching it. We still use product, chain, power, all those same ideas, but we just apply them in a slightly different way. So looking at a couple examples to see how we would approach these. So the first one has a equation that the y isn't isolated. So that's kind of the difference between whether it's an explicit equation or implicit. So for this first one, we could, if we wanted to, rearrange this equation. So let's bring the 10x to this side, and let's bring the 2y to the other side. And then if we wanted to, we could divide everything by 2. And that would simplify to, I'll rewrite it in a normal way, so we'd have y equals 3/2 x squared minus 5x. So what we've done is we've turned this equation that was implicitly written, so when it's implicit that just means the y is on the inside of the equation, and now we've written it explicit, which is sort of the normal way we would see these equations. So once we get to that step, now our derivative would be pretty simple. Just do our regular power rule, we'd get 3x minus 5. So this question, we could actually do it both ways. We could do it implicitly or explicitly. So today we're going to learn on how we could do this implicitly to see if it's any easier or a little bit different. This second example I got on here, we don't have a choice. Right? There is no way to take that equation and rewrite it as y equals whatever. Because we have a y and a y squared term, it's not going to be possible. So we have to learn how to do implicit derivatives, then we'd be able to do these questions either way. So the first one we could still do it the exact same way we did, but we could also do it using implicit derivatives. So let's figure out how implicit works before we look at a couple more examples. So any equation that could be written as y equals, you have the option, do it either way. So these first two examples I have on here, this x squared plus y squared equals 12, or even this second one, they're written implicitly because the y and x are kind of mixed up, but both of those we could rewrite them as y equals. So what we're looking at for these kind of questions is we're going to try to solve them without making them y equals. What we're going to do is we're going to try to implement a chain rule. So it's not going to be chain rule like we did for equations, but it's just a way of being able to do these in a slightly different manner. So what happens is we do not change the equation, we just leave it the way it is. We do the derivative of each term. So like for this first one, derivative of x squared would be 2x, derivative of 12 would be 0. So really the only thing we got to figure out is how do we do the derivative of y squared with respect to x, right? Because remember, we're always doing the derivative of the equation with respect to x, and that's where we have to be careful. So how the chain rule works is if you had a term such as y to the fifth, the question is what's that derivative going to be? So how do we turn y to the fifth into a derivative with respect to x? So if you look at the way this is written, we have the derivative of y to the fifth with respect to x. Well, we can't do that because how do you do the derivative of y if we want x as being our variable? So what we do is we change it to be the derivative of y to the fifth with respect to y. That we can do. Derivative of y to the fifth with respect to y is 5y to the fourth. We just use our normal power rule. But because we did the derivative of y with respect to y instead of x, we have to times it by dy dx. And you can kind of see from if you think of it like units, this dy and this dy would cancel. So what we'd have left over is the same d over dx that we wanted in the first place. So basically the trick is we just do the derivative of the y term, whatever it is. So if I gave you something like y squared plus 4x equals 7, do the derivative of the y term the way it is. So the derivative of y squared with respect to y is 2y, but we have to times that by dy dx. Derivative of 4x is 4, derivative of 7 is 0, and oops, that should be 0, and then we're basically done. So the only other sort of difference with these is we won't get dy dx equal to whatever, we have to rearrange and solve it. So we just basically do our derivatives of each term, and then from here we would move the 4 to the other side. So that'd be negative 4, and then we would divide by 2y, and that would be our final answer. So this one would be negative 4 over 2y. We could cancel out a 2, and that's it. So the derivatives are actually quite easy implicitly. You just have to be careful of the y terms. Make sure you multiply it by dy dx, and then the rest. So let's do a couple examples. So this first one, we have x squared plus y squared equals 15. Again, we could rewrite it as y equals if we wanted to. And let's actually do it. Let's try this one both ways. So if we took this equation and rewrote it as y squared equals 15 minus x squared, and then if we square rooted both sides, we would get 15 minus x squared rooted. And remember, we could change that to a bracket to do a chain rule. So we'd have 15 minus x squared to the 1/2. So now if we were to do our derivative, we would get 1/2 times our brackets to the negative 1/2, 15 minus x squared, and our derivative of the inside would be negative 2x. So that would simplify to negative x times our brackets. And if we wanted to, we could rewrite that as negative x divided by the square root of 15 minus x squared. So both of those answers are good. So was it hard to do the question this way? Not really, but we had to do the chain rule. So let's try it again, but using implicit, and you can see it'll actually work a little bit simpler. So do the derivative of x squared would give us 2x. Derivative of y squared is 2y times dy dx because of that y term. Derivative of 15 is 0. So now if we solve this, we get, bring the 2x to the other side, would be negative 2x, and we divide by 2y, and we're finished. So that would equal negative x over y. Does that answer look the same as what we had before? Not really, but if we compare the two, if you kind of go back to our starting y equals, and if we were to plug that in to our first derivative that we got, right, the root is root 15 over x squared is just the y term, which you can see matches exactly what we got when we did it implicitly. So the difference with implicit often is you get easier derivatives, which is nice. The downside is often we're going to get a y as part of our answer. But we could always substitute if we needed to. And again, remember these are talking about slopes. So in this case, if I was to say calculate the slope or calculate the equation, instead of me just giving you an x coordinate, I'd have to give you the y coordinate as well. So in this case, I'd have to give you something like an x of 1 and a y coordinate of root 14. If we did that, we'd be able to plug it in and calculate our slope at that location. So it works almost the same other than you need the y coordinate. Okay, so let's look at, this is the one we had on the title page that we couldn't do by rearranging. So let's try this one with implicit because that really is our only option. So if we take this equation the way it is and let's rearrange let's do the derivative the way it is. So derivative of 2y would be 2 dy dx. Derivative of y squared, 2y dy dx. And the derivative of 3x squared is 9, or 3x cubed would be 9x squared. So you can see, only thing that's a little bit more difficult with this is we get 2 dy dx's. So just like you do with anything else in math, we want to common factor those out. So let's rewrite it where we bring this one to the other side. So we'd have 2 dy dx, take away 2y dy dx, that's equal to 9x squared. Then we want to factor out a dy dx. Remember, dy dx is a slope, so we can treat it like a variable, just factor it out. So you'd have 2 minus 2y left over, and then divide those brackets, and we're finished. So you'd have 9x squared divided by 2 minus 2y. And we're done. So often, quite easily, the implicit will be a quicker, easier way to go than trying to do it any other way. So we got one more sort of scenario that causes a problem sometimes. So if you look at this equation, it's very similar to what we just did, except the problem is the y isn't by itself. We got a x to the 4th times y in that middle term. So it's that middle term that we got to be careful about, and what we have to do is we have to treat it like a product rule. So do it just like any other product rule, except we got to separate those apart. So what's written here is a little confusing, so let's just ignore that. Let's just do our normal product rule steps. So if f is x to the fourth, its derivative would be 4x cubed. If g is y, its derivative would be 1, but because it's y, we need to times it by dy dx, and we're good to go. So if we go back to the question now, derivative of 2x to the 5 is 10x to the fourth, so that one's good. The derivative of our middle term will be this product rule, so we have to do our normal product rule. So multiply those two would be 4x cubed y plus the other two, x to the fourth times dy dx. And then our last term, derivative of y to the fifth, would be 5y to the fourth, dy dx again because of the y, and derivative of 36 is 0. So you can see with this one it works the same, other than we get, oops, I didn't need this dy dx in the front. So we get the exact same sort of idea we just had on the last question. The only difference is we use the product rule. So for this one, we would factor out our dy dx terms. Let me write that down below here. So if we factor out the dy dx, we'd have x to the fourth plus 5y to the fourth. And let's bring our 10 and the 4 to the other side. So that would give us negative 10x to the fourth minus 4x cubed y. So our final answer then, let's just divide out those brackets and we should be finished. So we should have the negative 10 x to the fourth minus 4x cubed y divided by the brackets, which was x to the fourth plus 5y to the fourth. And we're done. We don't need to simplify any further. We could on the top, you can see we could take out a common factor of like negative 2x cubed, but it's not really going to do much because there's nothing that would cancel with on the bottom. So that's it. We just stop there and we're done. So you can see still the same process. Do the derivative of each. If you have a y derivative, put on a dy dx. And the challenge with this one was this product rule in the middle. We just got to remember to follow the regular product rule steps. So I have one more, and it's very similar to what we just did, except I want you to calculate the slope at that coordinate. So we don't do anything differently. Still follow our implicit rules. Still do your normal derivative steps. We just plug in that coordinate at the end. So let's do the product rule on this first part. So if we call f 2x, our first derivative of that would be 2. If g is y, derivative of that would be 1 times dy dx. So let's write out our product rule step. So we'd have, multiply those two first, so 2y plus 2x dy dx. Derivative of 15 is 0, so we won't need to write that. And then on the other side, we get minus 6x from the derivative of minus 3x squared. So that's pretty good. So all we need to do is rearrange this equation. So we'd have minus 6x minus 2y. Then we just divide by our 2x in front, and we're done. So in this case, because we have a 2 as a common factor, we could simplify that first if we want. So let's go ahead. Let's even take out negative 2. No, let's just do 2. Take out a 2 on the top, we'd get negative 3x minus y. The 2 that's on the bottom would stay, so we can cancel out these 2's. So our derivative would just be minus 3x minus y over x. So again, remember derivatives are slopes. So now if we're trying to calculate the slope, we would just plug our coordinate 1, 6. So x is 1, y is 6. And then on the bottom we just have x of 1. So you can see our slope in this case would be negative 9. And the rest of this would be the exact same. So we've got our slope. If I asked you what is the normal slope, do the negative reciprocal, so that would give us positive 1/9, not negative. Right, so our reciprocal, if we wanted the normal, would give us 1/9. If we wanted to figure out the equation, let's just do the regular tangent equation. We have a slope of negative 9. We know our coordinate was 1, 6. So plug that into our our equation, solve for b just like we normally would, bring the 9 to the other side would give us 15. So our tangent equation would be minus 9x plus 15. So it works the exact same as we did before. The only thing that's different is we're using implicit now to calculate the slope. And again, we just need that x and the y coordinate in most cases to help us figure out the slope value. And that's all for implicit. We're done there.